Archaeological excavations at the beginning of the 20th century in the lands of ancient Mesopotamia gradually changed our understanding of the past. When researchers first began to systematically study the ruins of Babylon, they expected to see a familiar picture of an ancient city, massive walls, palaces, traces of crafts, but layer by layer, a different story emerged before them. A story of a civilization that knew not only how to survive, but how to create a complex, thoughtfully designed, and comfortable living environment. For a long time, it was believed that human development progressed linearly, from primitive tools to complex mechanisms, from simple settlements to modern cities. But the discoveries in Babylon suggested that reality may have been far more complex. Some engineering solutions of the ancient inhabitants appear so sophisticated that it feels as if we are looking not at the beginning of a path, but at one of its peaks. One of the most discussed finds was a small ceramic vessel with metal elements inside. It was discovered near modern Baghdad. The construction was simple: a copper tube, an iron rod, and traces of an acidic substance. When reconstructed, the device proved capable of producing a weak electric current. Scholars still debate its purpose. The most cautious hypothesis is electrochemical gilding of jewelry. But even in that case, it implies the practical use of a phenomenon that official science associates with a much later period. However, the true strength of ancient Babylon was expressed not in individual objects, but in the systematic organization of the city. Beneath building foundations, archaeologists discovered a network of channels made of fired clay. The pipe joints were sealed with natural bitumen, allowing water to move in a directed flow and under pressure. This indicates an understanding not only of construction, but also of the behavior of liquids in closed systems. The organization of urban space is particularly impressive. Streets formed a clear structure. Residential districts were arranged according to access to water and air, and the architecture of buildings took the region's climate into account. In a hot desert environment, the primary challenge was not heating, but cooling. And it was here that ancient engineers demonstrated remarkable ingenuity. Beneath the city, a network of vertical shafts connected to underground channels was discovered. Hot air entering these shafts cooled and was pushed into residential spaces. In essence, this was a system of natural ventilation and air conditioning that required neither fuel nor mechanical devices. Humans did not fight the climate, they directed it. No less remarkable was the use of light. In deep interior spaces where there were no windows, no traces of soot were found. This indicates that lighting was not based on the constant use of torches. Nearby, archaeologists discovered polished metal surfaces capable of reflecting and directing sunlight. Light was not created, it was redirected. The architecture of Babylon also demonstrates an understanding of another physical phenomenon, the propagation of sound. In some rooms, the shape of the walls and the placement of vessels created a speech-amplifying effect. Even a quiet voice became clearly audible throughout the space. This was not a decorative feature, but a functional use of acoustics. Excavations of craft districts revealed a high level of material processing. Stone slabs were polished to a mirror-like surface. Microscopic traces of treatment indicate rotational motion of the tool. This suggests the use of mechanical principles, not merely manual labor. Metal tools found in workshops demonstrate resistance to corrosion. Their composition differs from simple copper or bronze alloys. This indicates practical knowledge of material properties and the ability to control them. Researchers paid special attention to toothed mechanical elements. The transmission of rotation is fundamental to any complex machine. Even if the devices were primitive by modern standards, the principle of mechanized labor was already present. In agricultural zones, systems of automatic water regulation were discovered. Float mechanisms opened and closed the flow depending on the liquid level. This allowed fields to be irrigated without constant human involvement. Natural processes became part of an engineering solution. Residential buildings also demonstrate a high level of thoughtful design. In some structures, heat distribution systems were found in which warmed air circulated beneath the floor. This provided even heating without smoke inside the pomeshania. Ventilation channels sometimes contained filtering elements made of plant fibers and metal. They trapped dust and sand. This indicates an awareness of air quality as a factor of health. Archaeologists also discovered materials with fire-resistant properties. Coatings on wooden structures prevented the spread of fire. This points to a systematic approach to urban safety. The financial and administrative life of the city was also organized at a high level. Seals and markings on objects demonstrate methods of protection against forgery. Unique patterns and complex manufacturing techniques indicate a developed system of authenticity control. Babylonian engineering was evident even in food storage. Ceramic vessels with a special wall composition created an environment that prevented spoilage of their contents. This is an example of the applied use of the chemical properties of materials. All these elements form a unified picture. Babylon was not a collection of isolated achievements. It was a city functioning as an interconnected system. Water, air, heat, light, and space formed a controlled environment. The main conclusion of archaeological research is not that the ancients possessed fantastical technologies. It is something else. The level of practical engineering thinking in the ancient world was significantly higher than long assumed. The history of human development may not be a continuous line of progress. It resembles a sequence of rises and losses. Knowledge can accumulate, disappear, and re-emerge. Babylon shows that a civilization can reach a high level of organization without modern science, electricity, or industrial machinery. Through observation, experience, and an understanding of natural processes, people created complex solutions from simple materials. The ruins of the ancient city remind us that progress is not only the invention of the new, but also the ability to preserve what has been achieved. Beneath the layers of sand lies not merely the past. There rests the experience of a civilization that knew how to turn the laws of nature into the foundation of everyday life. And perhaps the most important discoveries about the past still lie ahead. But the discoveries did not end there. As excavations progressed deeper, researchers began to notice that many of the ancient city's engineering solutions were not isolated inventions, but parts of a unified philosophy of construction. Architecture here did not merely protect against the external environment, it managed it. This became especially clear in the study of water-related systems. The city was located in a region where life depended directly on the behavior of rivers. For this reason, ancient builders devoted enormous attention to controlling flows. Canals did not simply deliver water. They regulated its movement, pressure, and distribution. Research has shown that many canals had complex branching systems and regulating sections. In some places, special chambers were discovered where the flow velocity decreased, allowing sediment to settle to the bottom. This prevented clogging and extended the service life of the canals. Such solutions indicate a practical understanding of hydrodynamics. The life of the city was closely connected with the Euphrates River. It provided water, food, transport, and energy. At the same time, it posed a threat. Floods could destroy entire districts. Archaeologists discovered that riverbank fortifications were built with consideration of current strength and seasonal water level changes. Stone blocks were laid at an angle, dissipating the energy of the flow. This solution is still used in hydraulic engineering today. Findings related to information storage proved no less interesting. In administrative buildings, archive rooms were discovered with a carefully designed microclimate system. Wall thickness, room orientation, and the placement of ventilation channels created stable temperature and humidity. This ensured the long-term preservation of documents. Researchers note that for ancient inhabitants, the preservation of knowledge was no less important than the production of material goods. Archives did not merely store records, they were protected from fire, moisture, and the destructive effects of time. Excavations of residential districts also revealed a high level of social organization. Houses were built according to a modular principle. Rooms were grouped around inner courtyards that served multiple functions, providing light, air circulation, and rainwater collection. Space was functional and rational. The layout of the streets is also of interest. They were arranged with consideration of prevailing wind directions. This allowed the city to be naturally cleared of dust and excess heat. Wind became an element of urban infrastructure. Craft districts played a special role. Workshops were discovered where production processes were organized sequentially and efficiently. Work zones were arranged according to a clear logic, from raw material processing to the creation of finished goods. Such spatial organization reflects an understanding of production as a system. In one such district, remains of mechanisms using rotational motion for material processing were found. Although the devices themselves survived only fragmentarily, traces of their operation are evident. Stone and metal surfaces bear characteristic patterns produced by mechanical action. The study of metallurgical remains showed that ancient craftsmen were able to control melting temperatures and alloy composition. Analysis of slag indicates the use of different heating regimes. This points to a developed technology of metalworking. An equally important aspect was the organization of the city's supply system. Archaeologists discovered storage facilities with a well-designed system of preservation. Space was divided into zones, each with its own temperature and ventilation conditions. This allowed products and materials to be stored for long periods. It gradually becomes clear that the ancient city functioned as a single organism. Infrastructure was not created randomly. It was designed with consideration of the interconnection of all processes. Research shows that the inhabitants of Mesopotamia perceived the surrounding environment not as a hostile force, but as a system of patterns. They observed nature and transformed those observations into practical solutions. This approach is evident even in small details of everyday life. Utensils, tools, and building materials were all selected with regard to the properties of the substance. The choice of form, thickness, and composition was never accidental. An interesting example is the use of clay. This material was applied not only in construction, but also to regulate indoor temperature. Clay has the ability to release heat slowly, creating a stable microclimate. Ancient craftsmen used this property deliberately. With each new discovery, it becomes clear. What we see is not a set of isolated achievements, but a culture of engineering thinking. The inhabitants of the city did not invent for the sake of experiment. They solved specific challenges of their environment. Archaeological data also indicate a developed system of measurement, standardized brick sizes, recurring building proportions, and precision in planning point to the existence of unified units of length and volume. This is the foundation of any technical culture. One of the most striking aspects remains the durability of the urban system. Many structures retained their functionality for centuries. This indicates an understanding of longevity as a key principle of construction. When researchers compared all the discovered elements, a picture emerged of a city that did not merely exist, it was designed. Space, resources, and processes were integrated into a single structure. Today, the ruins of Babylon are perceived as a reminder of the complexity of human history. They show that the level of development of past civilizations cannot be judged solely by the presence of modern technologies. Главное достижение древнего города заключалось не в отдельных изобретениях, а в способности создавать устойчивую систему жизни. Это была инженерия среды, основанная на наблюдении, опыте и рациональном использовании природных законов. История этого места заставляет по-новому взглянуть на саму идею прогресса. Возможно, человечество уже не раз достигало высоких уровней организации, но не всегда сохраняло их. Пески времени скрывают не только разрушения. Они скрывают опыт, который еще предстоит осмыслить. И каждое новое открытие напоминает, прошлое может оказаться сложнее и мудрее, чем мы привыкли думать.